Hello and welcome to this free training on using R in investment and risk analytics. Today we've got Mark here with us. So Mark, I'll pass it off to you and I'll let you introduce yourself first.
Thank you, Vincent. Okay, I'll start indeed with a small and quick background. I've been in the financial industry for 15 to 17 years, roughly. Large part of that with investment banks. Some examples: Credit Suisse, BNP Paribas, ABN AMRO. And I've always been on the dealing room, working and structuring with derivatives, finding solutions for our clients on their investment portfolios. And a large part of the work that we did in these financial markets environments and landscape is we worked a lot with Excel, PowerPoint, and Word. And the beauty is that in all those years, I've actually never ventured out of this environment. It's so common for organizations to have Excel, PowerPoint, etc. on their desktop and to work with that. Now, over the last 2 to 3 years, and this is going to bring us to the presentation today, I've discovered that there are a lot of open source solutions out there that can actually increase my efficiency and be there for us, that I can do complicated analysis very fast. And I'm doing that with the capabilities that I'm using a huge community worldwide that has taken time to build amazing applications and to share with others. So today we're going to talk about what are open source solutions. We're going to talk about R, why specifically R. We'll give some background about R, and we're going to talk about exactly what can we do with R. Presentation should take around 30 to 40 minutes. Now, let's start off. So, first of all, before we talk about R, what is open source software? Now, open source software basically, as it's stated here, is software where we can actually see the code behind it. A lot of the applications that we use, and this is the same for Excel, is kind of point and click. Click on a button and then it opens up this, it opens up, let's say, a new graphic for us, a formula, but we don't know actually what's happening behind the scenes. With open source software, we can see the source of the code. And the beauty is, it means we can work with that, we can learn from it. Now there are two types of licenses at the moment. We have open source software and we have the free open source software. And most open source software packages typically are free, but it's not always the case. And R is an aspect where it's open source and it's free. And I think it's very important because there's a huge amount that we can learn from it. We can leverage on what's being built by others, and it really actually can help us in terms of our day-to-day jobs. It really gives us kind of a catapult effect, and we're much more efficient and can do much more in a given day. But it's also there, it helps us with learning much more about those aspects that we're typically struggling with. So, what are other areas of open source that you might be familiar with before we go into R? WordPress. I think most people are familiar with WordPress. That is open source. The browser Firefox is open source. MySQL, kind of a database management. LaTeX, it's all open source. And a lot of the people that worldwide been using this leverage of this. It's free, it's therefore extremely cost efficient, but it also helps us be far more efficient. R is in that list too. So what is R and when did it originate? So R basically originated 20 years ago at one of the universities in New Zealand. And that's quite interesting for such a small country. But two professors decided that they actually wanted to build an application that was very similar to S, but they wanted it to be open source and free. So they started working on their open source called R. And the beauty is they wanted to share with their students exactly how something like this worked. And over those 20 years, it's become one of the most popular software packages out there at the moment. It's growing extremely fast. Around 2 million people worldwide use it. And so why do they use it? And this is where I come to this slide. If we use open source just like R, it avoids reinventing the wheel. So many times in my career, I've had people build all kind of applications in Excel for us, and they had to Google it, find the exact formulas, put it into Excel, knowing that easily other people in the same organization, and these organizations are typically very large, are doing the exact same thing already, have done it. And normally in these large organizations, you're not aware of that. They've been building this, or there are certain political silos, barriers, let's say, and therefore we keep on building something that's already been built 1,000 times. So open source helps you stop, let's say, reinventing the wheel. It's great for prototyping. Some people would like to build applications that not particularly maybe built in open source, but they want to keep it closed, and can use still R as open source, build it there, see exactly how it works, and then move to another software package. It drives innovation. Over the years that I've actually used R, it's helping with so many issues that I had, let's say, in complications in financial analytics, but it also helped me see a much wider field. Given that there's so much in a package like R, on a given day that we have maybe a spare half hour, we can dive into R, and it gives us so many other areas to discover that helps us with innovation. It's a great community, and a lot of the people that I know in actuarial profession, but also the risk investment side and finance, all use R. And given this community, there's been a lot of packages built for these professional sides, and that's the beauty. There are at least 5 to 6 different packages in R that are related to actuarial profession, maybe at least 30 links to finance, if not more, the same for investment. So that's the beauty. The community keeps on building on a software package like this. But it also can provide insights. If you, for some reason, organizations are not allowed to use open source software, they have to go commercial, a package like R can give you amazing insights on actually what do you need from these commercial packages. So some clients have used R, then discovered what they exactly needed, and based on that, then went to a commercial package, knowing that they wouldn't be wasting that many dollars. And therefore, you can actually save a lot of money by not buying commercial software that you're actually not fully going to use. Now, funny enough, and that's what I mentioned in my career, organizations still use a large amount of spreadsheets. So in this analysis that they've done, you can see that spreadsheet is still in the number 6 and number 5 spot as how much is being used for investment performance and investment risk. And that's quite interesting. With all the financial packages out there, like a Bloomberg or a FactSet, we can see that spreadsheet still is a number 5, which is very interesting. Because in my opinion, and regulators have mentioned this too, spreadsheets are prone to errors. And it's very hard to follow the steps of a user who built that spreadsheet to know exactly what he was doing. So we're going to now touch upon exactly what R is, how it works. We're going to give some examples, and I'll show you exactly how powerful it is. So in a day-to-day kind of work environment, what we do, for me at least in the financial analytics side, is first of all, I download all the data that is required. Now R can link to a Bloomberg or an Excel or to Reuters, to Axioma, so a lot of the data, if you require the professional data, I myself can link it actually to Yahoo or Google, and get all the stock data that I require. Then I can do risk analysis with this, do the performance attribution, do a lot of backtesting that is required for portfolio analytics or risk analytics. I can do Monte Carlo simulations with R, all kind of calculations on derivatives. There are at least 5 or 6 packages that are all around derivatives, so it's also a great learning source if you want to learn more about derivatives. But the most powerful part for me in regards to R is that it can build automated risk reports. So that means that I'm not spending time. If I have to update a presentation or a report once a week or once a month, that I'm copy pasting all kind of graphics out of Excel into PowerPoint or putting that into Word documents. No, R can do this in one go. What it does, it will download the data for me, it will do all the analysis that I've predefined, do all the calculations, and it will automatically output that into a PDF document. It can be a Word document, but it can also be a presentation. And these presentations can be PowerPoint presentations, but they can also be presentations that are on the web. And towards the end of this presentation, I'll show you exactly how that looks like. We can even build dynamic reports. So what can we do with R in terms of financial analytics? This is a whole list. I'm not going to walk through all of them, but as you can see, it's quite a fair bit of analysis that we can do. Given that it's open source, we can see exactly how all the programming has been done. We can check it, but it also means that if we are very comfortable with these packages, we don't have to actually understand the full code, but we can actually work with it and see the results. And we can always compare the results to any other package. Towards the end, you can see there are 5 to 6 actuarial packages, and that is still growing. Most of these packages have been built by professors, by universities, but some of them have also been built by market practitioners. And the beauty is that given that we've got 2 million users by now, I think, in R, a lot of them check for the bugs in there. So it's quite proof, soundproof to say. Now, when I speak about packages or libraries, what I actually mean when I compare it to Excel is that if you look at Excel, sometimes we have add-ins. So one of the most used add-ins is a solver. So we can say, add that to Excel, please. The same we can do with R, and that's what I mean with a package or a library. In R by now, there are around 7,000 libraries. So that's equivalent to saying Excel has access to 7,000 add-in packages, which are obviously very large. Some examples of the packages or libraries that I commonly use for financial analytics. I'll explain the top one, that is QuantLoad. That helps me with basically downloading stock data directly into R, which then I can, within maybe 20 characters of code, I can actually then backload into an Excel sheet if I want to. So it's extremely powerful. Here's an example of the reports and the data visualization that I've done for financial analytics. As you can see here, these are 6 graphs. I'll quickly walk you through this graph. There are around 100 stocks. So I downloaded the data for 100 stocks. I calculated exactly their drawdowns that took place between 2007 and 2009. And I put that also according to their current performance since 2007. So something like this is quite a fair bit of analysis, calculations, and visualization. And if I were to do this in Excel, I could easily spend a week building this, especially together with these graphics. In R, this can be done under half an hour. The code helps with getting the data, and it helps me basically with doing the analysis because everything's been pre-built already, and the data visualization packages are extremely powerful. They've been known to be very powerful, and they're often used by other organizations. One example of a well-known organization, Facebook used R to generate one of their graphics in their annual report. And other organizations also use R. So Wall Street Journal, they use R. The Economist once in a while uses R. So a lot of these organizations use R for its capabilities in terms of linking to open data and doing the analysis and data visualization. This is an example of where I downloaded the historical daily returns of the S&P 500. As you can see here, I've got the data since 1990. And in total, we have around 25 graphics here. If I were to build this in Excel, it would take me a huge amount of time of building each graphic, copy pasting, and putting into a framework like this. And this is where R is extremely powerful. This is only a couple of lines of code, and I'll show you exactly the lines of code in the next slide. This is the only thing we need to do. The part in the gray boxes is the code. So The first gray box you can see here, we're loading the two packages or the add-ins, let's say. Then the second gray box is the one line of code that I download the data for the S&P 500. Then I'm reforming the data into an appropriate format. So that's another 2 lines of code. And the final line of code is the plot. So as you can see, this is 1 line of code for this graphic, which is extremely powerful. Here's another example. These are financial ratios that are often used for financial analytics and performance analytics, and this is in a word cloud. So many people that are developing and working in R create their standalone packages. So part of the discovery in R is also knowing which packages to actually use, and I have around a database of 50 different packages that can be used for all kinds of different variations in terms of data visualization of financial analytics. This is another example. Here are 12 funds, and they are compared in terms of their cumulative return since 2000 to a benchmark. Their red line is the cumulative return, and the green line is their outperformance. R is very good at this, and as you can see, it shows the results in one graphic, and this is only a couple of lines of code. This is an example of the type of risk analytics that can be done with one of the packages called performance analytics. Now, also the beauty behind these packages is that it's well documented in terms of the research that they've used for the calculations and formulas. So for this particular package, this is all the documentation research that they've used to double check all the formulas and to build this. And there goes a huge amount of time in building these packages. Now, it's great that so many people do this. It really helps with sharing the knowledge that is required to do proper financial analytics. This is another example. Here we've built the efficient frontier. Now, for me, this is a great example. Back when I was still with the investment banks working on the dealing room, I had juniors basically build this. And it took them 2 to 3 days to build the efficient frontier based on 20 funds or 20 ETFs. They had to Google the information. And funny enough, for sure, somebody else in Europe or maybe in the US would be building this too, or another department. In R, everything is already pre-built. People have already built it, so we don't have to reinvent the wheel. This can be done with a couple of lines of code again. I'll show you this on the next slide. So, for building the efficient frontier, this is used by our metrics package, and it's by done one of the universities in Europe. As you can see, we have 3 packages that we load in, then we download the data. Then you can see that I'm adding the data together. I give the code for the efficient frontier, and then I build the efficient frontier. So this is done very quickly, very easily, and it's much faster than if we would have to do this ourselves in Excel. What else can be done with R? We can do benchmarking, and we can do historical backtesting. This is an example of a portfolio that is back-tested against the benchmark, and we can see when it underperforms and outperforms the benchmark. We can see how the volatility is against the benchmark. So the underlying benchmark is the blue line, black line, and the portfolio is the red line. But obviously, we're looking for maybe multiple portfolios, and that can easily be done. 1 extra or 2 extra lines of code, we can build graphics like this together, and nice overviews. So to summarize, why is using open source like R so powerful? First of all, there's no license fee. It's free. Anybody can use it, and that's the beauty. Secondly, it's used by a huge community worldwide. Now, R is extremely popular in Europe, in the US, Asia, and many people use it to do high-end, complicated analysis. This could be statistical analysis, this could be client data analysis, it could be analysis on Twitter profiles, what people are basically talking about. We can use it also for client data. Thirdly, it's able to communicate with a lot of other packages. So if you do not want to use open data, you can also get data from Bloomberg or Reuters. It easily speaks to Excel. You can get any type of Excel sheet into R, CSV files. It links to C++ or C, or even C#, Python, Perl, etc. So it's extremely powerful, and it's not just standalone. It can talk to any other language. And many organizations actually use R to gather a lot of data from different ends. So from Bloomberg, Reuters, maybe a program like Axioma, and then put it all together and can then do some analysis and then present it to the board. It's extremely powerful in financial analytics, and it's very good at data visualization. I would, if not say, actually the best one that I'm familiar with. And it's a great platform for reproducible research. So many times I spent hours and hours looking at Excel sheets trying to understand how to use it or exactly how it's being built by somebody else. And the biggest problem is with Excel sheets is that often within organizations there's rotation, people leave, and eventually you end up using an Excel sheet that you don't fully understand the steps that are being taken. With R, you can see exactly steps taken and why. So does R, given everything that's been said until now, does it have any disadvantages? Most of the people say it has a steep learning curve. To me, if you go on the self-learning path, indeed it can be quite challenging. But if you do a training for 2 or 3 days, to me, this is quite actually then gets you up and running very fast, and from there you can learn any other direction you like. People say it's not the fastest programming language, and that it's very challenging with large data sets. By now, there have been a lot of packages, and even commercial packages, that have workarounds with this. And most data is actually not big data that we're working with. It is actually small or tiny data. When we're talking about large data sets, we really are talking about data sets that are beyond, I would say, maybe 50 or 100 million data points. One of the disadvantages that people talk about is that not all add-on packages are of equal quality, and that's as important. That's why it's important to know exactly which packages to use. So those are the benefits, and what I'm going to do now is just quickly walk you through some data visualizations and some analysis that we've done, and also show you how powerful it is in terms of interactive graphics. So these type of dashboards, it's very common for banks or maybe insurance companies to create a risk dashboard. Most of them struggle with a huge amount of information to put that onto one screen, and R can work with this. So again, this is only 2 or 3 lines of code to generate a volatility index and a meter basic understanding of where the volatility is. This is another application where we show where the volatility is for this year compared to 2008. And here, this provides an overview of around 100 stocks, their performance between 2007 and 2014. And at the top, we can see for the selected stocks that are in red, the red dots, how their dividend profile has been over the last coming years. This is a quick example for dividend stocks and their dividend growth. For those stocks that have been colored compared to the color gray, those stocks have had a dividend growth that was beyond 200% over a selected time frame. And the bigger we can see in terms of the size of the text, the bigger the dividend growth was. So there's many variations that we can take. A more sophisticated analysis that has been done, that we've done in the past, is more on the financial side. It's Nelson-Siegel. So we compare the calibration of this format to the true markets. We then summarize this and to see where exactly the calibration errors were for each year. And as you can see, the calibration errors are basically summarized with box plots. And we can then do also comparison to another model called Svensson model, and then exactly see which model has the smallest errors in given years. All this can be done very quickly in R, given the pre-built packages that are available, together with very strong and powerful visualizations. So what I'll do now is I'm going to switch to some reports that have been generated by R, and that are actually reports that we can view in our web browser. So this is a report that's been built that summarizes the Singapore life insurance industry between 2007 and 2014. As you can see, it's a full report that has been generated by R. So I do not need to know anything about HTML or JavaScript or anything like that. R does that for me. It translates what I've built in formulas to an outcome like this. Now the beauty is that this is a report that we can send to anybody because R saves that on my hard disk, and then I can actually take that file and send that to anybody I would like. The beauty of this report also is that it's interactive, as you'll see here. If I would actually go to government debt, then I can show how much government debt each insurance company has in their portfolio and the percentage thereof. For example, it's hard to see exactly how much loans they have. However, if I would select this, then we can see that Great Eastern actually has the biggest loan portfolio percentage-wise. And this can also be done for any other graphics that we have here. So these are line graphs. So if you'd like to see the portfolio returns of a given insurance company, for example, I can do that here. So back to the interactive graphics within R. So as I mentioned before, R has the capability to translate all the analysis that is done in R into interactive documents. This is an example where it translates it into an HTML document, so basically a web page, and we can send this to anybody we'd like to share with. So I've done this, for example, some analysis, share that with people, and to give you an example here, this is an overview of the Singapore life insurance business from 2007 to 2014. And here you'll see that there are interactive graphics. So one good example is here in the overview of the company's assets. I could select government debt, and then you'll see that that part will be highlighted. The beauty is that I do not have to know anything about HTML code or CSS or anything like JavaScript, PHP. R does the translation for me. There are a couple of packages together with the software R Studio that basically is used with R, which helps us translating this to a web page like this. Now R can do the same for presentations that are interactive. Can translate it to PDF documents, Word documents, or can also translate it, let's say, to PowerPoint presentations. Therefore, if we have a presentation that we have to update on a weekly basis to send to clients, we can have R update the data automatically on a predetermined time, and it will also generate the report and it would save it to our hard disk. Nothing we need to know in terms of exactly how it saves it. A lot of the packages have been built for this and can be learned very quickly. So one of the other examples of the interactive graphics is here, for example, is portfolio returns. And here, if I again would select a certain company, you will see that the line is highlighted and the rest falls away. There are other examples that we have. Here I have an example of all the different types of graphics that can be done. This is an overview of one of the most famous packages, I would say worldwide within R. It's called ggplot2, and here it shows what is capable just with one package. A fair bit of different types of graphics can be made, and they all can be built within like 2 or 3 lines of code. Another example here that you see here is the geographical plotting, geospatial plotting, and this was something new to me. I've seen that many times with websites. I thought it was very powerful and very useful, and you'll see that indeed R is very easy to use to build these type of analyses. So I'm giving you another example. This is one of the graphics that shows you basically the S&P 500 daily return, and the location on the map here in the US is actually the headquarters of the S&P 500 companies. And here I split that between all the different sectors. So this is a graphic which again can be built very quickly within R. And that was it.
Okay, great. Thank you, Mark. And thank you everyone for joining us for this training. I hope you've enjoyed it and learned, given you ideas on how R can be benefit to you.